started. Okay, so mentally decide whether the solutions to each equation are real or not. So if I were to go about solving this, if I took the square root, what would I get? Real or not real solutions? Not real solutions. Why? There's a negative underneath that radical. So I would get a not real solution. I would get a complex solution, right? Okay, we learned about that last week. On this one, if I were going about solving this one, I would subtract 25 first, and then I would take the square root of both sides. Well, when I take a square root of a negative number, do I get real or not real? Not real. If I take the square root of a negative number, would I get a real or not real solution? It would be not real. Okay? Exactly. So if it has a negative underneath the radical, not real. Can you take a moment and try the next two? Okay? Tell me if they're going to be real or not real. Okay, when we take the square root, that would give us y plus 5. And when we take the square root of 0, that would just give us 0. So this would be an actual number, right? So that would be a real solution. If I take the square root of these, I have a negative underneath the radical. So what is that going to mean? Not real. Fantastic. Just a heads up, on your SAT, there is a question like this where it's like, how many real solutions are there? Okay. Huh? It's every third or fourth Saturday of each month, except for like, yeah, the SAT is the one that you have to take in order to get into college. No. No, there is no digital learning day tomorrow. I know there's like different things that are saying all these different stuff. There's not one that's listed on our Gwinnett County calendar. So that's crazy. That's what it like. I looked up the GCPS calendar. Like, watch. I mean, that's what I was thinking. I was like, worst case scenario, kids don't show up, right? Like, there's nothing on August 23rd. The first one is in September. Yeah. Yeah. And I'm pretty sure Jarrett would have said something on her morning announcement, so she didn't say anything. So, all right, let's go ahead and talk. So today we're going to talk about the quadratic formula to find complex solutions to quadratic equations. Okay. So I don't know how to pronounce this guy's name. Is it Karen? Karan? I'm not sure. Was using the quadratic formula to solve the equation. He wrote this. He noticed that the number inside the square root is negative, and then he said, this equation doesn't have any solutions. Do you agree with him? Yes or no? Do you agree with him? Yes or no? He said, the square root is negative. That means that there is no solutions at all. Doesn't have any solutions. Is that a true statement? No, that's wrong. Okay. And the reason why is because he has complex solutions. If there's a negative underneath this radical, that would mean that there's complex solutions. With me? All right, so let's actually simplify this out. Okay, shh. I can talk about it later. Okay, so when he plugged in, okay, the easiest way to do this is to simplify the outside, the inside, and the denominator. Okay, well, the outside's already simplified. What about the inside? What's 144 minus 164? Negative something. Negative 20. Just 20. All right, so we're going to get negative 20. Okay. And we know from last week that if we have a negative underneath the radical, okay, that's going to pull out as an I. All right, so again, we could make this negative 20. We're going to pull out an I. And what are factors of 20? 10 and 2. Okay, can we break 10 down into 2 and 5? That's fine. You could do it in a 4 and 5. That's fine. Okay, now we learned last week that if we have pairs on the end of this little tree, we can rewrite it, right? We can take out that 2. We'll have an I. And we're left with 5 underneath the radical. So here's a recap of that. I took this stuff right here. I broke it down into factors. If there was a repeat, that's where this 2 got pulled out. And then I'm going to take everything else that's in that equation and rewrite it. And I'm going to pause for a second and let you finish writing that. Okay, so once we get here, we can take everything that's on the outside and it's all divisible by something. So what are they all divisible by on this outside? They're all divisible by 2, right? Okay, so what's 12 divided by 2? 6. And what's 2i divided by 2? Just I. And 2 divided by 2 is going to give me 1. So our final answer is going to be 6 plus or minus I square root of 5. Okay. Now, I know that if this is a multiple choice question and I'm given this, okay, I would plug this into my TI-84 graphing calculator and hit simplify. Okay, and I'm going to show you how to do that a little bit later on this week. But that way, I can finally actually see the answer. Okay, again, I'll show you how to do that a little bit later. Yeah, but so this is going to be I because it's negative, and then 2 and 10. All right. So, okay, so the discriminant, okay, the discriminant is b squared minus 4ac. Okay, this is very familiar to what we just saw, where in the quadratic formula, we've got this. Okay. Okay, so we're going to take this and we're going to plug it into the quadratic formula. Okay, I'll always give this to you. So even on tests, I'll give you this formula. Okay, so the first thing that you need to do is identify your A, B, and C. So in this equation, we've got A is equal to 1, B is equal to 0 because there's no B term, and then C is going to be equal to negative 9. Okay, I suggest when you write this out, you write kind of tiny on your notes. Otherwise, you're not going to have enough space. Okay, so what you're going to do is you're going to take those 3 numbers and substitute into this equation. So I'm going to get negative 0 plus or minus square root of 0 squared minus 4 times 1 times negative 9 all over 2 times 1. All I did was I took these 3 numbers and plugged it into this formula. I'll give you a second to finish writing that down. Okay, so negative 0 is just going to be 0, so we're not even going to write that out. Okay, so this is going to give me a plus minus. Under the square root, we're going to have 0 squared, which is just 0. Negative 4 times 1 times negative 9 is going to give us a positive 36. And then in the denominator, we have 2 times 1, which is just going to give us 2. Okay. Again, we're going to simplify this. And that's going to give us 36 And when we take the square root of 36, we're going to get positive and negative 6 divided by 2, which can be simplified down into positive and negative 3. So our solutions are going to be positive and negative 3. Let me give you a second to finish writing that down. All right, so with the discriminant, what it basically does is it tells me how many real solutions I'm going to have. Okay, so the discriminant is all of that stuff that's underneath the radicals. So looking at our quadratic formula, it's all this stuff that's underneath. Okay, so when we simplified that, we got positive 36. So if you have a positive number, you're going to have 2 real solutions. So since it's a positive number, we're going to have 2 real solutions. What I'd like for you to do is I'd like for you to try to take this equation and plug it into this quadratic formula. See if you can simplify it, and then we're going to talk about it. All right, so checking in, making sure you're on the right track. So your A should have been 1, B is going to be negative 6, and C is going to give you 9. Okay, I'm going to write this over here just because I don't have any room. Okay, so this will give me negative 6, and I'll explain that in just a second, plus or minus the square root of negative 6 squared minus 4 times 1 times 9, all over 2 times 1. So the best way to actually read this quadratic formula is to say opposite of B, because B is already negative. So what's the opposite of being negative? That's going to be positive 6. So notice how there's a negative and a negative. That's going to make that positive. On the inside of the square root, negative 6 squared is going to give me 36. Negative 4 times 1 times 9 is going to give me negative 36. In the denominator, we have 2 times 1, which is going to give us 2. Remember, our goal is to actually simplify everything all the way out. So underneath this radical, we're going to have this 36 minus 36, which will give us 0. So the discriminant's going to be 0. And so we're left with 6 divided by 2, which is just going to equal 3. So notice how when our discriminant is 0, we have 1 real solution. Again, I know that's a lot of information. All right, so let's look at the last one. So what it says is A is going to be 1, B is 0, and C is going to be 9. So again, we're going to plug into the quadratic formula. Okay, so that's going to be negative 0 plus or minus the square root of 0 squared minus 4 times 1 times 9, all over 2 times 1. It's similar. There's just a sign difference. We're going to see it in just a sec. So when we simplify the outside, that's just going to give us 0. So we're just going to leave that positive and negative out front of the square root. 0 squared is just going to give us 0. Negative 4 times 1 times 9 is going to give us negative 36. And then in the bottom, we have 2 times 1, which is just going to give us 2. Okay, so again, once we simplify here, we're going to get plus or minus, and 0 minus 36. That's going to give us negative 36 as the discriminant. Okay, and that means we're going to have the positive and negative version of 6i, because when we take the square root of 36, that gives us 6, and there's a negative in that square root, so that's going to make that I. And when we simplify, that's going to give us positive and negative 3i. So notice how our discriminant was negative, So our solutions are complex. All right, so with the discriminant, we're going to substitute into that b squared minus 4ac. Okay, biggest thing is you got to make sure that it's in standard form. So for instance, on this first one, if we substitute in, we're going to get -6 squared minus 4 times 1 times 12. When we simplify, this is going to give us 36 minus 48, which is going to give us a -12. So that means that I'm going to have 0 real solutions. On number 2, you need to rewrite that and make sure that it's in standard form. What I mean by standard form is that you would have ax squared plus bx plus c equals 0 before you start moving anything around. So we're going to move that 17 to the other side. And so that's going to give me x squared plus 2 square root of 17x plus 17. Again, we're going to substitute this in to our our discriminant formula. So this is going to give us 2 square root of 17 squared minus 4 times 1 times 17. Now, if you type 2 square root of 17 with parentheses around it, square it into your calculator, that's going to give you 68. And then -4 times 1 times 17 is going to give us -68. So 68 minus 68 is going to give us 0, which is going to give us 1 real solution. Remember, you've got to make sure that it's in standard form first. So we're going to move that x to the other side. So this is going to give me 2x squared minus x plus 5. I'm going to substitute into that b squared minus 4ac formula. So this is going to give me -1 squared minus 4 times 2 times 5. So this is going to give me a +1 minus 4 times 2 times 5. So that's going to give me a -8 times 5, which is going to give us, let me rewrite this the other way, because otherwise we're going to get something crazy. So when you rewrite these, you want to move it all to the left-hand side. So this is actually going to change all of these signs. And so this is going to be -2x squared plus x minus 5. So when we plug this into our discriminant, we're going to get 1 squared minus 4 times -2 times -5. So this will give us 1. -4 times -2 is going to give us a +8. 8 times -5 is going to give us -40. 1 minus 40 is going to give us -39, which is going to give us 0 real solutions. Okay. Biggest thing with this is just making sure that your numbers are correct when you plug in. Okay. Okay, this is the last problem. We're going to skip over a couple of things. This is the last problem I'm going to ask you to do. I want you to solve the following equation using completing the square and the quadratic formula. Okay, so quadratic formula is what we did today. Completing the square is what we did last week. You should get the same answer for both. Okay, so go ahead and take a moment on your paper. You're going to solve it using the quadratic formula and solve using completing the square. Okay, so if I were to solve this, I would plug this into my quadratic formula. So this is going to give me negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 35, all over 2 times 1. Now I'm going to simplify. So on the outside, it's already simplified. Okay, so that's going to give us negative 10 plus or minus 10 squared is going to give us 100. And then 4 times 35 is going to give us that negative 116. Nope, guess we're not writing. That's going to give us that negative 116. Say again. 4 times 35? Oh, I'm sorry. Yeah, that's right. Okay. In the bottom, we'll have 2. So negative 10 plus or minus the square root of negative 40 divided by 2. Now we can simplify this, okay? So this is going to be broken down into 4 and 10 and I. And so this is going to give us negative 10 plus or minus 4i, or 2i, because we're going to take that out. Square root of 10 over 2. Everything on the outside is divisible by 2. Our final answer will be negative 5 plus or minus I square root of 10. If you did it the completing the square way, okay, so the stuff that we did from last week, first thing you would do is move that C term over to the other side. You would take B divided by 2, square it, and add it to both sides. So that's going to be plus 25 on both sides. You would factor, combine like terms over here. And notice how this is a very similar setup to what we have down here at the bottom. Take the square root of both sides. And so that's going to give us I square root of 10. And then we move that 5 to the other side. So x is going to equal negative 5 plus or minus I square root of 10. So you could do either one. It gets you the same answer. One is probably easier than the other, depending on whether or not you like to just like plug in, or you like to actually like work these other problems out, okay? Tomorrow, we're going to get a little bit more practice with this stuff. I need us to come in and actually try these problems, because you don't just get good at them by sitting there, okay? This is not like learned by osmosis. Technically, you learned this back in 8th grade and 9th grade. So I know it might have been a while, but you still know something about this, okay? So tomorrow we're going to get some more practice on this.